So electrochemistry is all around us.
And how about if you just pull like up to 2 with the Gatorade and 4 milliliters and mix them both into your cup.
Okay.
So do y'all know any common?
Pull.
So hold, like if I were you,
Yeah,
I'll,
pull on the
yeah, I'll
stopper.
pull it from here and I'll pull
Good
up.
examples. We have this Gatorade here, orange juice, lemon juice.
There you
those are
go.
also good
Nice.
examples. Stuff like sweat.
Okay, good. That's exactly 2. Right on.
That's
Now
2.
push it back into your cup.
Do 2 full syringes.
Oh, that works. All over you. That's okay.
All right, so that's the Gatorade.
2 full syringes.
Oh, really? Uh-oh. My bad. So how about if you pull it all the way up?
To get the electrolyte mixture, you're gonna make the
Actually, that's
mixture, and then you're
easier.
gonna be able to
But I guess
Yeah,
push
that's
it back
fine.
a little
Sure.
bit slower because it's gonna.
Not too fast this time. There you go.
Perfect. You're pro. How about if you actually do one more because the first one doesn't count?
So you can roll this dice to see the ocean water. You can roll it on the
It's more like an explosion of electrolytes, right?
All right, 2 parts ocean water.
Yeah, we're gonna
Then
find out.
spin it one more time.
Good.
There you go, Joe.
Awesome. Okay, so that's 2 parts Gatorade. Now, how about if you do? I
4
think it was
parts of
4.
lemon juice?
Yeah,
Yeah.
4 parts lemon juice. Oof.
You're gonna run out
This
of
is
lemon
gonna
So
be-
you get 2 parts ocean water and 4 parts juice. So take this over to Sam, and then it'll help you make your mixture. And do you want to spin?
It's gonna be already released. I've heard people who was on the price services that a lot of them straight up said we're not taking
So you get to spin again.
Okay, cool. So that's 1.
How's it going?
Good, how are you?
Good. You guys come in if you're interested.
Lemon
Yeah,
juice.
we are
Then you
doing
roll the
experiments
dice.
that
Good job.
involve splitting water.
That's 2.
We're doing it in a way where you create
4. Okay. So 4 parts lemon juice, and then I'll have you spin it one more time.
using a little spinner and dice over there.
Awesome.
Making electrolytes.
One more, that's
finding
3.
mixtures of everyday liquids.
Ocean water,
Then we
okay.
use a
So
battery,
4 parts lemon
reliable
juice,
battery to use smoke
2 parts ocean water.
Nice.
and
This
some
one
hydrogen,
over.
oxygen,
And some
There
more.
you go.
depending on the electrolyte you pick. You'll get very different water splitting rates, so they're collecting the data and then
Last
also
one.
populating
One
And now
it.
you have your electrolyte all ready to go.
And then using this kind of overarching theme as a way of talking about reproducibility, variability in science, like how do we go about measuring something, populating data. and
Beautiful.
using that to make
Okay, so now how about if you take your electrolyte to Evan and he's
Okay,
gonna
down
help
here.
you.
If you got any on you, feel free to use this to clean up your hands if you got any on you.
Can you clean up your clean up any liquid on your hands? On your hands.
All right, so there's a couple things that make our electrolyte a good electrolyte. One of the first is that we have a lot of water in the electrolyte, which is good. Do you know what water is made up of? Do you know the formula for water?
H2O.
H2O, perfect. So we have hydrogen and we have oxygen, and that's all around in our electrolytes. A couple other things that we need are some salt. So this has plenty of variety of salts in it. That's kind of what we use in the
2 parts
salt.
ocean water,
Salt
so
water
that's
with the
right
sweat.
here.
And another thing we have is high pH and low
Full
pH.
syringes
So for
and
low
dump
pH,
them.
we have a lot of hydrogen just ready to go. It's just hanging around.
And then the
So
other thing,
we're going to be doing a reaction called the hydrogen evolution reaction, where we're taking water and we're taking those hydrogens and we're forming hydrogen gas. So when we do peel off, and I'm going to take this and set up ourselves, we're going to peel off some of those hydrogens in water and we're going to combine them to form H2. Now, a lot of people see hydrogen gas, H2, as kind of an energy fuel of the future. And so it's a very good thing that we can make this from water. So we're going to do that right now.
for example, we have 2 people
So what we're going to do is we're going to set up our cell with some base electrolyte.
current one.
And then what these are electrodes. There's metal. So the metal is going to be a source of some electrons for us so that we can actually make the hydrogen gas. And the battery is going to set up our energy difference so that we have to pump some energy into the system in order to get our hydrogen gas. And the battery is going to do that for us.
Okay, let's see
So
what
see if I can set this up. Okay.
that's gonna turn out to be.
There we go. So we've now submerged one of our electrodes
All
in
right, so
electrolyte.
you have made your own custom electrolyte. Now we're
Let's
going to
see.
test it. We're going to see how
I
good
put this
your
down? Okay,
specific
there we go.
solution is at splitting water.
So we'll submerge both
So
of
we
our
have our little
electrodes
cell
so
set
that
up
the
here,
electrolyte is everywhere in
which
the
has
system. We
2
can get water from
electrodes in it,
anywhere.
which is going to be like a positive side and a negative side, just like in a battery has a positive and a negative.
All right. So
I
then what
have
we're going to do? Oh, that one
These
wasn't
little
very good.
tubes, which I'm going to also fill up with your electrolyte, just so we can fully
I'm not very
submerge
good at this
those
yet.
and see what's going on a little bit easier. Oops.
You gotta flip faster.
Yeah, I know.
It's like a water bottle on a water dispenser. You gotta flip them quick.
There we go. All right. So now we have our electrodes completely submerged, so when we supply our potential difference, our energy difference using the battery, we're gonna have a positive side and negative side. And so at our negative side, we're gonna be supplying electrons, which will give us our hydrogen gas from water. So let's go ahead and hook it up.
I'm gonna try this again.
So now we have our positive and our negative side, and it's actively working. So what we should see is at the negative side, we should be seeing some bubbles. And what could the bubbles be? Do you have any idea?
Okay, so we have our setup. You have your electrode.
So the water
your
is still in the
electrolyte with
liquid
two
form,
electrodes.
and so the bubbles
your
are
electrolyte is
gas.
conductive, so it
And so
allows
what do we think
current
is
to
forming
pass
the gas?
between these
Maybe
two sides.
hydrogen that we're taking.
We have our energy
Hydrogen
source,
forming
which is our
H2
battery,
hydrogen gas.
and we have a multimeter.
So do you see
this
some bubbles
multimeter
happening
is what
in
we
there?
use to measure
Nice. So we're
how
actually
much current is
performing a
moving.
reaction.
So how many
How do we know that we're
electrons
performing a
we're sending
reaction?
from one
Because
side
we
to the
can look
other,
and we
how
can
much
see it
reaction
there,
we're
and we can
driving.
look on here. And this is our
So if you're gonna
current.
grab
So this is
this
our
black
electrons
side
that we're actually
and
passing
open up
into
the
our
clips
solution
and
to
put it
form our
on the
hydrogen
right
gas.
electrode.
So the larger this number,
And I will
the more
help you with
electrons
the
we're
other
passing,
side.
the more reaction that we're actually doing. So as we see
Yeah,
that
so
we're
you
forming
need the
hydrogen
clamps
gas,
on
we see
there.
that we're getting a reaction. Fantastic. We're
Perfect.
getting
Okay.
7.7
we have a current.
7.5
Something's happening.
of current, which
If
I'm
we
going to
look
write down
inside,
here.
do we
This is a data
see
point that we
anything
can then
happening
use
here?
to make some Legos with.
So what if I? So if I look
So we've now made hydrogen, and we can
at this
compare
side
now
here,
our
do you
electrolytes
see
to what
anything
other people have
that
done in
could
their
indicate a
electrolytes to see
reaction is
what makes a good electrolyte,
Yeah,
high
so
salt,
there's lots
low
of
pH,
bubbles.
more water.
So when we
And
break
so
water
then I
down,
will
we
send
turn
you
it into
over
two
to
different
this
gases,
table to
hydrogen
compare
and
your
oxygen.
results, and I think
And so
somebody
this
should
is
be
what
able to
our
7.5. Did you bring your paper? You kept leaving your paper.
that we tested so far. So you can take that over.
All right, so 7,
Where your range is.
5.
Scale.
perfect.
7.5, yeah.
7.5, so you have 4 Legos,
Power 12 high.
and you find any 4 you want, make them in a stack.
And you probably have to find where Gatorade and lemon juice interact.
That's right.
So we're going to need the water to run our reaction because our
Perfect, so since it was mostly Gatorade, we start down here.
Oh, it's mostly lemon
And,
juice.
or, yes, mostly lemon juice. Then we start right here, and we come up all the way till you find Gatorade, which is right here. And now, let's see, you did the second observation there today, and you exactly matched the first person. So both cases, 4 stacks.
Okay.
And
Yeah.
so that's, we didn't know that ahead of time. And in fact, the way science works is we track the points, we measure what we have to measure, and we observe and then explain. And as you can see here, this is actually 3 years we've done this. This is the biggest variance I think we've found. And that means somebody came in today and measured this current with that formulation. Somebody came in and measured that current with that formulation. We track it, what we see is what we get. And then we have to explain it. We could explore it further. We could get statistics. But the big thing you see from this, the kind of take-home message, everywhere there's a big stack, we have a lot of salt.
Ocean water. Huh?
Everywhere there's a small stack, like lemon juice, we don't have much salt. So the salt is really, really important for water splitting. Even though the salt is not directly involved in the reaction, it facilitates the reaction, it lets it happen. Super important for electrochemistry.
Okay.
So, thank you.
All right.